Is it recording? All right, it's in silence. Okay, everyone. So today's topic is going to be number 4. As a recap, we already talked about things like rate of change. When I talk about it in words, we've done it. If you see it, you'll be like, oh, I recognize that. We talked about table of values last class or the previous classes, especially in the form of first differences. We talked about rate of change. We talked about rate of change and how to find it when we are given a graph. Today is that part. Okay, so I'll do a little thing here where I say this part done previously. Okay, this is new. So if you want to tell yourself that this is what you want to focus on for this particular lesson, and if you want the other stuff, you have to go to our previous lessons, numbers 1 to 4, then yeah, make yourself a note. Okay, as a recap, here we go. In words, I can give you something like this. It says the cost to visit a arcade is a one-time entrance fee of $5 plus $2 per game. What's the independent? What's the dependent? It might be a little hard to identify at first, but I hope you'll agree when I say, yep. What? Yeah, absolutely. This is my independent, AKA, that's my X value. Why? Well, English-wise, it says the cost is equal to something else. So this is dependent on something else, right? So therefore, that will be my Y. And of course, even if you have a hard time understanding with words, you can take a look at this table. Typically, the first column is going to be my X, not X here, it's going to be N, right? And my Y value is going to be represented by cost. So seeing this as my description, let's fill this in. If I go in and play 0 games, how much do I have to cough up? Yep, there you go, right? So this is going to be just $5. But if I played 1 game, I'm not going to insult your intelligence. You already paid your $5, but you spent $2 on the game. Make sense? Let's follow along. Rehan, question? No, of course not. I just want to show you that there is a pattern. Right? I played 4 games, I would have paid $8. I played 5 games, it would have been 10. So in total, my C, aka my dependent variable, will be 5, 7, 9, 11, 13, and 15. Yes.
Wait, what are we trying to do here? Give like plug the graph into the graph, bunch of numbers into the graph after graph it?
I want to show you that all of these
Match up.
are the same. They're all the same thing, but you have to be able to use all 4 styles, right? Because it's one and the same. People who don't like numbers, but you know they can think for themselves, they will understand that. People who don't like the English too much, but they can do their adding and subtract, they have their number sense, they will like that more. Some people that don't like both, but they enjoy their visuals, they would love a graph. But people who don't want all of 3 of these are going to help us figure out the equation. And you have to be comfortable, well, not comfortable, but you have to be capable of all 4 styles. There we go. As a graph, I'm going to fill in, the bottom is the number of games. This is the number, the amount of money, so cost. Let's do the x-axis as 0, 1, 2, 3, 4, 5, 6. The cost would be $0, $2, $4, $6, $8, $10, 12, 14, 16. So we've got, let's do a contrasting color. How about I do orange? If I play 0 games, I still pay $5. If I play 1 game, it is $7. If I play 2, that's $9, then 11, then 13. The beauty of a graph is that visually we see a pattern. I don't have to even count. I know exactly where the dot is. Yes? Yeah. Well, now we know. We know it, obviously we know it, right? But I want to make a point of being so annoying that you will appreciate the equation, okay? So bear with me here. I know I'm going a little slow. And that would be the trend because, you know, it goes on forever, right? Like, I don't know if I play one game, I don't know if I play a million games. So I draw an arrow. Here is where I connect what you already know with the equation, because frankly speaking, as you progress from this point on, I care very little about the words table of values by graphs. The equation is what we want to be able to do immediately. That's my final goal. Ready? Do you notice that every time, sorry, maybe I'll save that. You know what? No, let's do it. Do you notice that every time I increase by one, increase by one, increase by one, I am increasing by two, increasing by two, and increasing by two? So if I talked about the rate of change, the change in y as you change in x, 2 to 1, correct, or just 2. Okay, how about this one? If my run is 1, how much do I go up by? If my run is 1, how much do I go up by? If my run is 1, how much do I go up by? Every single time I'm going up by 2, 2, 2, 2, 2. So if I said, what's my rate of change? Well, I go up by 2 every time I go to the right by 1. Equation. My cost is the C. Ah, how awesome. What's my cost? What am I adding here? How would I write it as an equation? Well, what number is always there? Ron? Yeah, okay. So that's C, that's a dependent variable. But what is that going to equal? How much money do I have to pay? Okay, yeah, 5 is there. Can you finish it off?
Plus 2.
Well, yes. So we have the number of games as n, so that's right. And that's it. So I'm going to rearrange this as C equals the variable first plus 5. That's the better option, okay? Please put the variable first. And let's break it down. In black, what is this? What is this? What is this? Which will bring us to that. What is C again? Well, I'll fill that in for you. That's my dependent variable. Right? Therefore, that's my y value. What about n? Not rocket science. This would be the independent variable, therefore it's my x. What would you call my 5? We use this, we called it a certain thing last class. I didn't put too much emphasis on it. It's the amount, even if I play 0 games, it's the amount that I start with. It's my initial. This is my initial value. All that's left is the number 2. Do you see the connection? The number 2 that we're constantly multiplying here is this part, right? It's the $2 per game. Where else do you see 2 in the other options? That 2. That 2 in the equation, the 2 that I'm multiplying the x with, the independent with, what that number that is multiplying with the independent variable must represent my rate of change. So they are one and the same. From here on out, this is why it's important. It might seem simple, but this is important. Anytime I give you an equation of this sort, and you see the number multiplying with the x, that is my rate of change. So you know exactly what number I'm going up by. You know exactly what my slope, what my incline or decline is going to be. And in terms of words, you know exactly how much I'm going to change by every step of the way. That number has a big meaning behind it. So you have to consider what each part actually is telling us. That is my rate of change. Soak this in, because from here I have 1, 2, 3. I have, example on example on example, and I am going to essentially get you to create an equation without any of this. I give you a scenario and I want you to go straight to this because you can identify. What's the y? Identify. What's the x? Identify. What am I starting with? Identify. What's the rate of change? If you have those pieces of information, you can give me an equation. What's the final goal? What's the end game? I give you a scenario. You can convert words into math so you can solve problems out there, not in these 4 walls. So right now we're doing bang, 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 super slow. I get it. But I need you to go from here immediately to here to save time, to be efficient, to essentially do math. Okay? So let's try it. Example 1. So here it is. Jeez. Every step of the way, I am essentially going to ask you, hey, which of these is the y? Which of these is the x? Good. What am I starting with? And how am I changing? Good. Piece it all together. Here we go. Ooh. That's insane. Okay. Example 1. Alexis has 500 in her bank account. She deposits 50 every week. What's the initial value? In other words, according to this equation, what's my initial value B? And what's my rate of change M? Take a look at the sheet right on top where it shows you the key idea. The initial value uses the letter B. The rate of change uses the letter M. What are they? Based on this description. All right. I couldn't hear. Huh? Uh-huh. Sorry, I can't hear. I'm like going there. $50 on rate of change V1. Take it slow. Take it slow. The initial value, in other words, how much do I have right now in my bank account? It would be, thank you for the hand, 500. And then, as time passes, how much am I changing by? Yep. 50. Okay. Yes.
You also say also that you have like baseline, like the.
Yeah, you could think about it as baseline, as a standard, sure. And we go up or down depending on it, right? So from here, based on this scenario, what do you think is the independent? In other words, x. And what do you think is the dependent? In other words, y. I'll give this one to you because I think it might be a little confusing to see this. The dependent is, oh, I jumped the gun. Can I go back to the rate of change? Well, it's not just 50. Let's give it a unit. The rate of change is an increase of $50 per week. If you are having trouble figuring out what the X and the Y is, do you remember that rate of change is the change in Y over the change in X? That means this unit right here, the per something, that's going to be my X. And this top part right here, the dollars, that's the dollars, and that's right here, that's going to be my Y. What I'm trying to say is, if you know what the rate of change is, you already know what the X and Y variables are. So that's down here, that's the X, and that's here, that's the Y. So let's do this.
The rate of change always y over x.
Of course, yes. I'm gonna say let dollars, okay, let I don't know, A be amount in bank account. Let time W be number of weeks. And as a reminder, the A, the amount in the bank account, is my Y value. W, number of weeks, is my X value. Y is equal to MX plus B. That means my final amount is equal to rate of change, number of weeks, initial value. Yes. Come back safely. Priority. Question.
You say that the bank account, isn't that supposed to be outline? Because it's in the initial value.
Oh, no, the total amount. Total amount. Does that make sense? So it could be 500. It starts at 500, but it keeps on growing, right? So that's my final. It's like 500, and then 550, and then 600, and 650. So that's my Y value. Question?
Like that is W. So the W for the first one, like we did this, and then the lab would be W plus 50.
It would be, but that addition of 50 every single time is to show that we are adding 50 by how many weeks. So that extra adding of 50, we're trying to convert it into a multiplication. So think about it this way. If you plus 2, plus 2, plus 2, plus 2, plus 2, it's easier to be like 2 times 1, 2 times 2, 2 times 3, 2 times 4. That's why we rewrite it all as a multiplication. So try to use it as a multiplication and fit it in. Do you know your Y value? Do you know your X value? Do you know the starting value? And do you know your rate of change? Put it all together, a single equation tells you so much. Think about what happened. There were 4 pieces of information that we had to bring together for a single mathematical equation. That's where we want to get to. Every single one of these pieces has a meaning to it. Let's practice it. Yep.
I know the W stands for weeks probably, but why add the W there if you don't? It's like,
You don't though. How many weeks passed? Right? That's why we call it a variable. You don't know if it's 1 week that passed or 2 weeks that passed, but the beauty is this. I just started saving. How much money do I have? 50 times 0 weeks plus 500. So I start with 500. Does that agree with my story? Yes. I saved for 10 weeks. 50 times 10 plus another 500, $1,000. Does that follow my story? Yes. If the equation models the scenario correctly, this is so useful. Why? Oh, how much money do I have by the end of the year? Well, stick a 52 week in there and they'll tell you how much money you have. It makes it efficient. And that's the strength of mathematics. It's speaking a different language. And I'm hoping you'll follow along with me. Let's do another example. All right, everyone, I'm going to challenge you. I'll give you a minute. Read this story. Can you identify how much you start with? What my change is? What the heck the y value, the x value is, and what the heck the y value is. And if you want some help, if you can identify the rate of change correctly, the numerator and the denominator will tell you what independent and dependent is. Okay? Let's see. This plus this per topping. And here's a hint. It may not always be available to you, but if you see the word per something, it automatically means that it's a unit rate. It's some kind of fraction. It's 150 per something. And that fraction should tell you what the rate of change is. Look for the per. That's a key word. Is it always there? No, but it's a really good clue. Give you like another, give you a minute. Okay, looking at this, again, just from the English, just from the sentence, regardless of whether I have a topping or not, I know I'm paying $7. So that's my initial. My initial, AKA my B, is 7. Well, mathematically, I'm not even going to write the dollar sign. It's just 7. What is my rate of change? I'm going to use that word per as a clue. This is $1.50 per topping. And I know as a rate of change, that is y per x. So you can say, I'll write it as rate of change. Rate of change, M, is equal to $1.50 per one, or just $1.50. But it also tells me that my y value is here and my x value is here. So what's my independent? My x value. Independent equals number of toppings.
Independent?
And then my y value would be total cost. The rate of change will help. And does that work? Does that make sense logically? If I have more toppings, does my price go up? Yeah. If I have less toppings, does my price go down? Yeah. So it's independent affecting the dependent. It makes sense logically. Without math, it just makes sense. Yep.
Why is the why equal total cost and not 7? Because why not?
It could be $7. It could be $8.50 because I added a topping on it.
No, but I was like wondering why the dependent variable isn't just how much a small pizza costs without toppings.
Because you don't know if it's no toppings.
Well, I don't know, the one we above, it's sort of similar, and I was wondering why.
Well, no, it is similar, and you'll see why it's not just 7. Take a look. My total cost, since I defined it here, is equal to the number of toppings times $1.50 every time. So if I have 0 toppings, my initial value is 7. So 0 plus 7, that's just $7. But if my x happens to be 1, it's $7 plus $1.50. If my X happens to be 2 toppings, it's $7 plus $3, so on and so forth.
It's written the same way as the last question was written with the equation, and I'm just wondering why. it's
Well,
not.
even in the previous example, the final equation was, what was the question again?
A equals
Yeah,
15
it's-
times
Every week I'm adding $50. I already have 500 in.
That's why I was thinking that this one would be the same, because you already know that these cost $7, so you're just adding more topics.
Right, so what's the difference between these two? So why are you, I'm trying to understand your question. Why do you think it's just $7?
No, just like, I don't know, value of the dependent variable is 500. The dependent variable is not 7, in this question, so I was wondering why it's different.
I wrote this as 500.
Yeah,
I shouldn't have written this as
oh,
500.
it's not,
No,
oh, then that's what's.
the B value is right here. This is 500. That's 500. Okay, so let's get to it. Your final equation is here, and again, it depends how many toppings do you have. It will tell you the final cost. And this is a fun fact. Again, it could be a business model. I don't know. It's something interesting. I had a friend, okay, someone I know, and their parents ran a pizza shop. Now that pizza shop was not like Pizzaville. It wasn't like Pizza Nova. It wasn't like Ziolo. It wasn't like Pizza Hut. It was a independent chain, and their title was free topping pizza. What does that mean?
They gave up free toppings?
You can do whatever you want on your pizza, but you pay a flat rate of something for that pizza. What do you think? Whether you have 1,000,000 toppings or you have 0 toppings, let's pretend you have to pay $15 for that pizza. How many toppings do you normally have on your pizza anyways? 1? Oh, you just like choose 2? Cheese and pepperoni? What? 3 or 4? Okay, so you got like your what? You have your cheese, you got your mushrooms, you have, I don't know, what else? Who does their Hawaiian? Who actually enjoys pineapples on their pizza? Sort of. Okay. Some people do. A regular Hawaiian, think about it. There's cheese, there's pineapple, there's bacon, or ham, or both. Okay. So let's say there's 4 toppings. Plug it in. Y is equal to 4 toppings on this pizza. How much is it? Do the math, take out a calculator, $1.50 times 4 plus a 7. Even 13. Who's making more money? Right. When will this be cheaper? Or sorry, when will that actually be cheaper? Whoa. See, there's a little bit of math that goes into this business model, doesn't it? Right? I'll let you know. If that random person comes in and wants 6 toppings, getting this is cheaper. But majority of the people don't want 6 toppings on their pizza. They want 3 or 4. So saying free topping pizza, it's sort of like a sneaky ploy in charging more money for their pizza. Does that make sense? I don't know how many people have that business sense, but I thought it was pretty interesting. I thought it was a great idea. But I think they did fine, but it was really funny because one time we went in and we put in every type of meat on that pizza, right? Because we're friends, right? I think that pizza weighed like 6 pounds. Like just like a regular pan pizza actually weighed 6 pounds, more than a dumbbell. Anyways, let's keep going. Example 2. This time I'm going to give you a chart. Initial fee, $5, $2 extra for every kilometer. Soon. Okay, let's try to finish this. Let's see. All right. let's do this. Total cost in the beginning, even if I don't travel, it's immediately $5. Ryan, up here. Then 7, then 9, then 11, then 13, then 15. So I'm not doing much math. I'm actually just counting by 2 because I already know that the rate of change is 2 per kilometer. Well, yes, $2 per kilometer. So I already know what my rate of change is. But I can easily translate that into a graph. So let's do it. I have distance. It's probably going to be the letter D, right? And this is cost. And that's going to be letter C. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got $1, $2, $4, $6, $8, $10, 12, 14, 16, 18, 20. Now, if we were to follow suit, I'll do it in green. How about orange? 0 kilometers, $5. 1 kilometer, $7. 2 kilometers, $9, and so forth. My graph would look like this. Like that. Could you try CDE? I'll give you a minute. Identify the initial value based on the chart or the graph. Identify the rate of change based on the chart or the graph, and give me an equation using the letters C and D. My Y value is C, my X value is D. Shouldn't take you long.
Wait.
I'm gonna ask you to do it in like 30 seconds. Yes.
For the first one with the table and stuff, it's the same question all the way.
Mhm.
How is 0 kilometers $5 if you don't use it, the taxi service? I know there's a flat fee of $5, but if you don't actually go anywhere, they charge
They do though.
you.
If they stop and they put you in, they push the button, immediately you owe them $3.50. Well, now it could be like
Oh,
four
I don't
something.
want to taxi, you get out, but they'll charge
Well,
you.
no, then you leave. But if you take that service, there is initial flat
I
fee.
know there is, but what I'm saying is like it goes 0 kilometers.
Let's say you go 500 meters over a block.
So what?
So, yeah. So the initial means, what am I starting with? That's all. Right? So we've got what is the initial value? It would be that $5. What is the rate of, so B is equal to 5. What is the rate of change? That would be $2 per kilometer. And that's going to equal mathematically a 2 over 1, right? Which is just a 2. Create an equation to model the total cost. Remember, that's my Y. If I travel D kilometers, Y equals mx plus b. Cost equals 2 times the distance traveled plus 5. How much? In other words, what's the cost with a 50-kilometer ride B? So in other words, what's C if D is 50? C equals 2 times 50 plus 5. Find the calculator. So the efficiency, yep. Yeah. The efficiency of an equation, as opposed to counting and adding a $2 amount every single time, this is the goal. Get an equation, model your story, calculate for it. My final example before we go for a longer break is example 3. This example gives you a T-chart, but it's going to be a little sneaky on you. Look at it very carefully. Some of you are still writing this, that's fine. I want to ask you to solve part A, part B, and if you do part B correctly, part C should be very simple. I'll give you a minute. More than enough time? That should be more than enough time to make a guess. Initial value? 0. Bam, right here. When x is 0, my y is 0. But be careful about the rate of change. Before I even tell you what the answer is, I want you to catch it. Some of you, most of you might have gotten it right. Some of you guaranteed this class is not doing it perfectly. Remember that the rate of change is a change in y over the change in x. So this, I'm pretty sure most people did. How much am I increasing by every step? Good, but the slope, or the rate of change is not 1.4. How much do I increase by in the x value to do that? No, the rate of change, I change by 124 in the y value every time I change by 20 in the x. So this actually equals, it's going to be a division of 124 with 20, 6.2.
So you take the x and the y and the x.
Yeah. Up until now, the x value always increased by 1, so you didn't have to do that. But remember, the rate of change is always delta y over delta x. So determine the model. My x value is going to be my volume, and my mass is going to be the y. So I'm going to say let B represent volume in gallons. Let M represent mass in pounds. I don't know why it's in imperial, but whatever. That means my y value, which is mass, is going to equal rate of change, x intercept, or sorry, x axis plus 0. Let's be honest, we're lazy. We don't need to write that. Plus 0 doesn't change anything. This is my equation. Before you go on a walking break or whatever, I'd like you to try this. It's the exact same thing in example 4, only you will see that the slope is a negative value because it's going down. See if you can figure out exactly what number that is. Once you do so, you can go for a quick break. Know that, yes, I would like you to be responsible with homework at some point today. Because I don't see you on Thursday, but tomorrow's lesson, I'm going to assume that you have reviewed all of today's lesson, right? So it's heavy, but you got to do it. Okay. Any questions? Yep. Which part? Oh, it's a negative. It's a negative value. Yeah, so negative, that's a VE. So sorry, that's my shorthand from university. Negative. You know what I mean? Yeah, it means it's a minus number. So see if you can figure that out while you do example 4 as practice. You have to do your best guess. So the question is, so for everyone else, the question was, how do you know what the heck is the actual point? There are some points that are nicer than others. Like for example, this point, and that point are directly in the intersection of these lines. Points that are not directly in the crosshairs of the grid, you may not want to choose.
So every single line.
Yeah, in other words, any of these points are okay. However,
How do you?
which one is more accurate?
How do you know which ones are close to the, could be the whole line?
Correct. That's the beauty of a graph. It could be any of these points.
But then how do you know how much is going down?
Well, you choose the ones that are nice. Hey, take a look. Do you see this point right here?
Yeah.
You can confidently say that's going to be 0.70. Wouldn't you agree? This point, I have no idea. None of these are nice. I'm going to get some decimal. I don't like it. But, whoa, that doesn't look bad. It's right at the intersection. That would be what? 32, 40. 40, comma, 50. That's 40 right there. And all these points, I don't like it because it's going to give me some kind of decimal. Oh, but I see another point that's nice. That's 80, comma, 30.
But how do you know how much it's going down by? So obviously there's points that are going down by 20.
Well, tell me what the difference in the rise is and tell me what the difference in the run is.
But my question is, if all of those are points, then what is the difference? What is it going down by 20 have to do with anything if there's more points?
Well, it's a proportion. The amount that I went down here is the same proportion as I went down. The same fraction. It's like this. What you're asking is, how do I know if it's this? Or how do I know if it's this? But they're the same.
Like in the first one here, it like goes down by 124 each time. And it goes up by 124 each time, so it's up by 20 each time. Now, how do you know how much is going up if it's a graph of each point? You going up by 1?
No, yeah, but it's a proportion. If it goes up by 1, this will go down by, let's say, 3. If it goes up by 2, this goes down by 6. It's going to be a proportion. So it doesn't matter where you choose. All right, let me give you an example. Ready? If I move from 0.70 to 40.50, how much did I move to the right by? Five boxes, but it went from 0 to 40. So what did I move to the right by? 40. Good. Now from here to there, how much did I go down by? 20. So my run is a positive 40, but I went down by negative 20. Exactly. So as long as I have 2 points anywhere, it'll be the same as if I went 1